Hello everyone, welcome to this video. In this video, we are going to learn about hypothesis testing by critical value method and confidence interval method. So let's begin with the hypothesis testing using critical value method. So in critical value method, there are 5 steps that we need to follow while performing the hypothesis testing. So let's go through these 5 steps first, and then we are going to solve the example. So first step is to read the problem and then state the null and alternative hypothesis. Once you have your null and alternative hypothesis, we have to identify the claim and state the test used. So we have to identify whether it is one tail test or two tail test. And also we have to determine whether it is the Z test or T test. Step 2, we have to find, using the significance label, we have to find the critical value. Number 3, we have to compute the test statistics using the formula. Generally, for computing the test statistic, the formula will be observed value minus expected value over the standard error. And once you have your critical value and the test value in step 2 and 3, we have to check whether the test value is in the rejection region. If the test value lies in the rejection region, we reject the null hypothesis. If the test value is not in the rejection region, then we do not reject the null hypothesis. So once we have that in step 5, we state the conclusion for our hypothesis testing. So let's take an example and try to use these 5 steps to perform the hypothesis testing. Example, a researcher claims that the average wind speed in certain city is 8 miles per hour. So that is the claim. A sample of 32 days. So in order to test whether the average is 8 miles per hour or not, a sample of 32 days were taken. And the average on those 32 days were 8.2 miles per hour. The standard deviation of the population is 0.6. At alpha equal to 0.05, we have to test if there is enough evidence to reject the claim. And we are asked to use the critical value method here. So clearly you can see that the first step is to write the null and alternative hypothesis, and the claim is the average wind speed is 8 miles per hour. So your first step is mu equal to 8 miles per hour, and that is the claim. That is the claim. Now the alternative hypothesis will be opposite of this. So we write mu is not equal to 8 miles per hour. That is the alternative hypothesis. Now, when you look at this, there is not equal to sign here, meaning of that is this is two-tailed test. And also the population standard deviation is given. So it must be two-tailed Z test. So this is, let me write that. This is two-tailed Z test for mean. Okay, so this is two-tailed Z test for mean. So that's our first step. First step is to write the null and alternative hypothesis using the claim. And then we have to decide whether it is one-tailed test or two-tailed test. And also we need to decide whether it is a Z test or T test. Now in step 2, if you go back and check here, in step 2, we have to find the critical value using the significance label. And when you say the critical value, that is the value that separates this 0.5% from the tail or from the rejection region on the tail. So this is a two-tail test. So when we draw the normal distribution here, the rejection region will be on the tail. So let's draw the normal distribution. Okay, so suppose that is my standard normal distribution. Meaning of that is the mean is 0 and standard deviation is 1. And along the x-axis, you have the z values. Because this is a two-tailed test, the rejection region is on the tail, so we can show the rejection region here. So rejection region is on two tails like this. And this total area on the tail will be equal to significance label 0.05. And that is divided into two parts. That means on each tail, you have 2.5% or half of 0.05, which is 0.025. 0.025. So the values here are, this is your Z critical, this will be negative of that value. One will be positive, other one will be negative. So what we are going to do is we are going to find that critical value. So in order to find the critical value, you can calculate any. You can find the Z positive or negative, and you know that one will be positive, other one will be negative, so we can write them. So Z critical will be equal to, we'll get plus or minus. So we are looking for the Z value here when the area is 0.025. That means what we can do is in our calculator, we should be able to use the inverse functionality and find the value. So what we do is to find that critical value, we use inverse normal. So let's do it. Inverse normal. And then the area is 0.025. Mean is 0. Standard deviation is 1. And if we simplify this using calculator, if we use inverse normal functionality on our calculator, the value will be, you can check with the calculator, you will get 1.96. The value on the right will be positive, on the left will be negative. So we can write plus or minus 1.9600. So that is the critical value. So we got the critical value. Now, what we have to do is we need to find the test statistics. So that is the first step here. This one is the second step. Now in third step, we have to find the test statistics using the formula. So now the test statistic will be, so let me calculate that test statistic right here for step 3. So test statistic is given by the formula. In this case, this is the Z test. So Z equal to X bar minus mean divided by sigma over the square root of n. So this is just like this one, observed value minus the expected value over the standard error. So if we plug in the values, so Z will be equal to X bar, that is the mean of the sample, is 8.2 minus mean of the population is 8. So minus 8 over the population standard deviation is 0.6 over the square root of the sample size is 32. And if we simplify this, we'll get Z equal to 8.2 minus 8, that is 0.2 divided by 0.6 over square root of 32. It is 1.8856. So the test statistics is 1.8856. That's our third step. Now, if you look at this value, Z equal to 1.8856, this one, Z critical is 1.96. This is 1.96. And here the Z is 1.88. 1.88 is a little bit before that. So here is our test value. So that dot represents the test value, Z. Now you can clearly see that this Z is in the acceptance region. It's not in that red rejection region. It is here in the acceptance region. So meaning of that is we do not reject the null hypothesis. In fact, we accept the null hypothesis. So I'm rejecting the alternative and I'm going with the null. Okay, I'm rejecting the alternative and I'm going with the null because this calculated Z value is in the non-rejection region. So that is the meaning of that fourth step here. So the test value lies in the acceptance region. So we fail to reject the null hypothesis. So what we write is, let me write a sentence for that. Since Z, that is the test statistic, is in the acceptance region, is in the acceptance region, we fail to reject null hypothesis. We fail to reject the null hypothesis. That means we are not rejecting the null hypothesis. Instead, we are rejecting the alternative hypothesis. That means we are putting the check mark with the null hypothesis, okay? Because our first one was the null hypothesis. So this is the null hypothesis. And this one is the alternative hypothesis. So clearly, we are not rejecting the null. We are accepting the null hypothesis. That means we support the claim. So meaning of that is in fifth step, we are going to write the conclusion. That is, there is enough evidence to support the claim that mean is equal to 8 miles per hour at this significance level, 5% significance level. So let's write that conclusion. So the conclusion will be, there is enough evidence. There is enough evidence to support the claim, and the claim is mean is equal to 8 miles per hour, okay, at 5% significance level. 5% significance level. Meaning of that is, when we say 5% significance level, it's like we are 95% confidence that the average is equal to 8 miles per hour. So this is how we can perform the hypothesis testing using the critical value method. So you can clearly see we found the critical value here. We got the test value, and we have the critical value to separate the acceptance region from rejection region. And when we put that test statistics here in the diagram, we saw that it is in the rejection, it is in the acceptance region. So we accepted the null hypothesis. So this process of performing the hypothesis testing, it is called the critical value method, or remember, sometimes it is also called the traditional method of hypothesis testing. Okay, so that is the first part. Now we are going to move on to the second part, or the next type of hypothesis testing. And here is that. So this method is called the confidence interval method. So in confidence interval method, again, there are a couple of steps that we need to follow. It's also going to be pretty much 5 steps, including the conclusion. So first step, you have to state the null and alternative hypothesis. Then you have to identify the claim. And we also need to identify which test to use, Z-test or T-test, one-tail test or two-tail test. Then after that, we have to find the critical value using the significance label given. And using that critical value, what you have to do is we have to find the confidence interval. Okay, we have to frame the confidence interval. And once we do that confidence interval, we have to check whether the hypothesized parameter given in the null or the alternative hypothesis lies in that interval or not. Okay, if it lies in that interval, then we accept the null hypothesis. If it does not lie in the confidence interval, we reject the null hypothesis. And finally, we write the conclusion. In confidence interval method, one thing to note here is This method cannot be used for one tail test. You cannot use for left tail test or right tail test. This is exclusively for the two tail test only. Okay, this is only for two tail test. So let's take an example. Here is the example. Let's see what is going on in this. A researcher claims that adult hogs feed a special diet that have an average weight of 200 pounds. So that is the claim there. A random sample of 10 hogs has an average weight of 198.2 pounds. At a standard deviation, and the standard deviation of those 10 is 3.3. At alpha equal to 0.05, can the claim be rejected? And you can see the claim is the average weight is 200 pounds. We are asked to use the confidence interval method by assuming that the variables are normally distributed. So let's begin with the hypothesis here. So here, what we can see is for the null hypothesis, they are saying that the mean is equal to 200 pounds. Mean is equal to 200 pounds, and that is the claim. That is also the claim. So we have to check whether the mean is 200 or not. So the alternative hypothesis will be, because we are not talking about greater than or equal to, meaning of that is the mean is not equal to 200 pounds will be the alternative hypothesis. Now, clearly we can see that this is a two-tailed test because the alternative hypothesis has not equal to sign. So this is two-tailed test. And if you read the problem carefully, sample size is 10, average of the sample is 198.2, and the standard deviation of the sample is 3.3. That means the population standard deviation is not given. So when population standard deviation is not given, this is the t-test. So we can write this is two-tailed t-test. Two-tailed t-test for mean. So that's our first step. So in first step, we stated the null and alternative hypothesis, and we also decide whether it's one-tailed test or two-tailed test, and also decide whether it is the z-test or t-test. Now what you have to do next is, at this significance label, alpha equal to 0.05, we have to find the critical value. So in order to find the critical value, now we have to draw that t distribution. So let's draw the t distribution here. Okay, suppose that is my t distribution. So when I say t distribution, we must have the degrees of freedom. So here, the degrees of freedom is, your sample size is 10. So that is 10 minus 1. Degrees of freedom is n minus 1. So that will be 9. Degrees of freedom is equal to 9. Along the x-axis, we will have the t values. And because this is a two-tailed test, this one, alpha equal to 0.05, is divided on two tails, so 2.5% each. So if we want to label that, so this one and this one, they are equal to 0.025, 0.025. And the values here are the critical values, TC, and that must be negative. One is positive, the other one is negative. So now, in order to find this, we can use any of the area and do this. So let's work on the left tail here. So this value will be, T critical will be, if we want to find T critical, that is equal to, we have to use inverse T. Area on the left of this value is 0.025, 0.025, and then the degrees of freedom is 9. And if we use our calculator, this value will be negative 2.2622. negative 2.2622. That is this value. The other value will be positive. So we can write plus or minus. One value is positive, the other one is negative. So we got the T critical. So that is the second step. In first step, we have to write the null and alternative hypothesis, decide which test to use, and using that significance label in step 2, we have to find the critical value. Now what we do is at this significance label, we have to construct the confidence interval. That is our third step. Third step is to construct the confidence interval based on that information. So in order to construct the confidence interval, what we normally do is at the center of the interval, we'll have the point estimate. In this case, we are talking about the mean. So that will be the sample mean, which is 198.2, 198.2. And then we find the lower and upper boundary of the interval by subtracting the margin of error. And we find the upper boundary by adding the margin of error. So that means to complete this interval, what we need to do is we need to find the margin of error. And to find margin of error, we know that the formula for margin of error is equal to T critical multiplied to sample standard deviation divided by square root of n. That is the formula. So if we plug in the values, T critical, we got it here. You can use plus or minus. Both will work. So I'm going to use positive value 2.2622 multiplied to S. The sample standard deviation is 3.3 divided by square root of 10. And if we simplify this using calculator, it is equal to 2.3607. 3607. So then what we can do is we can subtract this value to get the lower boundary, and we can add this value to this one here to get the upper boundary. So if we perform this subtraction, okay, 198.2 minus 2.3607, it is 195. Okay, let me rewrite like this, 195.8933. Similarly, if we add these two, 198.2 plus 2.3607, the upper boundary will be 200.5067. That means the confidence interval that we are constructing is, let me write here, confidence interval will be, if I just write up to one decimal place, this is 195.9, 195.9 up to, this one will be 200.5. That is the confidence interval. So in the third step, we found the confidence interval. Now what you have to do is we have to check whether our claim lies in this confidence interval or not. In the hypothesized mean, the claim here is mean equal to 200 pounds, and it lies in that interval. Okay, if it lies in that interval, we accept the null hypothesis. So what we do is we're going to write that sentence now. Since mu equal to 200 lies in the confidence interval, we accept null hypothesis. We accept null hypothesis. Okay, we accept null hypothesis because this mean lies here. If it does not lie in that interval, in that case, we reject the null hypothesis. So here, what we have done in the fourth step is we check whether the hypothesized parameter lies in the confidence interval constructed or not. If it lies there, we fail to reject or we accept the null hypothesis. If the hypothesized mean does not lie in that interval, in that case, we reject the null hypothesis. So in this case, we accept the null hypothesis, we reject the alternative hypothesis. That means we are supporting the claim. So meaning of that is, at 5% significance level, there is enough evidence to support the claim. So let's write that conclusion. Hence, at 5% significance level, at 5% significance level, there is enough evidence to support the claim at 5% significance level, there is enough evidence to support the claim, which was mean equal to 200 pounds. That was the claim. So that's how we can perform the hypothesis testing using the confidence interval method. So in this video, we look at hypothesis testing using critical value method and hypothesis testing using confidence interval method. I hope you find this video helpful. Thank you so much for watching.